Hello everybody. In this lesson we are going to study about solving quadratic equations using quadratic formula. So far we have studied how to solve quadratic equations by the method of factorization, by the method of completing the squares. Now in this lesson we will study about the quadratic formula and how we can use that formula to solve quadratic equations. Welcome to the lesson. We all know what is the standard form of a quadratic equation. What is it? Ax squared plus bx plus c is equal to 0. Where of course a, b and c are real numbers and a cannot be equal to 0. We know this is the standard form of a quadratic equation. Now we can use the quadratic formula to find the roots of this equation. And the formula is x is equal to minus b plus or minus square root b squared minus 4ac over 2a. This is called the quadratic formula. Now if you observe this formula, look at the term b squared minus 4ac under the square root. Now b squared minus 4ac, if this is equal to 0, can you guess what is going to happen? The square root term will vanish. So we will be left only with x will be equal to minus b by 2a. So we will have only one solution to this equation. So when b squared minus 4ac is equal to 0, we will have only one solution or one root for the equation. What will happen if b squared minus 4ac is less than 0? That means the term inside the square root is negative. Now, when the term inside the square root is negative, there is no real value for a negative square root. So there is an imaginary solution. So the quadratic equation will have no real solutions. When does this happen? When b squared minus 4ac is less than 0. What happens when b squared minus 4ac is greater than 0? Then the square root will have some value, some real number. So x will be either minus b minus square root b squared minus 4ac over 2a, or x will be minus b plus square root b squared minus 4ac over 2a. So in this case, when b squared minus 4ac is greater than 0, the quadratic equation will have two roots or two real solutions. So there are three cases over here. One, when b squared minus 4ac is equal to 0, in which case there will be only one solution. And the second case, where b squared minus 4ac is less than 0, there will be no real solution. And in the third case, where b squared minus 4ac is greater than 0, there will be two real solutions. Now b squared minus 4ac is determining how many solutions this quadratic equation has. So b squared minus 4ac is called the discriminant. What is it called? It's called the discriminant because it discriminates the number of solutions and the type of solutions the equation has. Now let's look at the formula. Let's use the formula and solve few problems. Let's try this. Find the roots of the following equations if they exist. following quadratic equations if they exist using the quadratic formula. So the first equation is 3x squared minus 5x plus 2 equal to 0. So what's a over here? It's 3. B is negative 5 and C is 2. What is a quadratic formula? X equal to minus b plus or minus square root b squared minus 4ac over 2a. This is our quadratic formula. Let's first determine how many roots this quadratic equation has. How do we do that? By figuring it out, what is b squared minus 4ac equal to? Let's see what is b squared minus 4ac equal to. B happens to be negative 5 squared minus 4, a which is 3 and c which is 2. So this is going to be 25 minus 24. That's going to be 1. So b squared minus 4ac is 1, which is greater than 0. So this will have 2 real roots. Now we can easily take the values and plug it into the formula. X is equal to minus b, which is minus 5, plus square root b squared minus 4ac, we already found out it's 1 over 2a. And the other value is x is equal to minus 5 minus square root 1 over 2a. Now we can solve this part. X is going to be equal to 5 plus 1 over 6. So x is equal to 6 over 6, 1. We found one root. And over here, x is going to be equal to 5 minus 1 over 6. X is going to be equal to 4 over 6. X is equal to 2 over 3. So we found the other root. So the two roots of the equation are 1 and 2 over 3. Very easy. Apply the formula. Use b squared minus 4ac to determine how many solutions this equation has. And then if b squared minus 4ac is less than 0, if it's negative, then there will be no real solution. So you don't have to proceed. Great going. Let's try a few more word problems now. Let's try this. Find two consecutive odd positive integers, sum of whose squares is 290. Let the smaller of the two consecutive odd integers be x. The smaller of the two consecutive odd integers. So the next consecutive odd integer is going to be x plus 2. The question says sum of their squares. So their squares and the sum of their squares is equal to 290. Now we need to solve these problems. So we can go ahead, x squared plus, now x plus 2 the whole squared is in the form a plus b the whole squared, which is a squared, x squared, plus 2ab plus 2ab plus b squared, which is 2 squared, equal to 290. We can simplify. X squared plus x squared is going to give us 2x squared plus 2x times 2 is 4x plus 2 squared is 4. We will bring the 290 on this side of the equal sign, minus 290 equal to 0. So now our equation will become 2x squared plus 4x minus 286 equal to 0. but these are pretty big numbers. The common factor is 2, so we can divide each term by 2. So now we will land up with x squared plus 2x minus 143 is equal to 0. Now over here, a is 1, b is 2, and c is negative 143. We can apply the quadratic formula and solve this equation, and let us see what we get. So applying the quadratic formula, x equal to minus b minus 2 plus or minus square root b squared, 2 squared, minus 4ac divided by 2a. So this is the formula. So now we can move on. X is equal to minus 2 plus or minus, if you do the calculation on the square root, it's 576 over 2. X is equal to minus 2 plus or minus square root of 576 is 24 over 2. So we have now x is equal to minus 2 plus 24 over 2, or minus 2 minus 24 over 2. So x is going to be equal, in this case it's going to be 11, or x is going to be equal to negative 13. But we are dealing with consecutive odd positive integers. So you are dealing with positive integers, so x equal to negative 13 is ruled out. So the first positive integer is x is 11, and the second positive consecutive odd integer is 13. You can verify this very easily. 11 squared plus 13 squared, you will land up with 290, which is the case. Great. Reduce it into a quadratic equation, apply the quadratic formula, and get the answer. Excellent going. Let's try this problem. The shape of a rectangular park. A rectangular park is to be designed whose breadth is 3 meters less than its length. So let's try to figure out as we read. Let the breadth of the rectangle be x meters. So the length is going to be x plus 3. The length is 3 meters more than the breadth. Its area is 4 square meters more than the area of a park that has already been made in the shape of an isosceles triangle, with its base as the breadth of the rectangular park. So the base of the triangle is the side of the breadth of the rectangular park, which will also in this case be x. Let's continue our reading. Find its length and breadth. Now, what will be the area of the rectangle? Area of the rectangle, this rectangle, its length times width. So that is going to be x times x plus 3, which is x squared plus 3x, and meter squared, of course. Now what is the area of the triangle? This is rectangle. What is the area of the triangle? It is half base. The base happens to be the breadth of the rectangle. So half times x times height, which is 12, and that's going to be 6x. The question says the area of the rectangular park is 4 square meters more than the area of the park that is already been made in the shape of an isosceles triangle. So the area of the rectangular park is 4 more than the area of the isosceles triangle. So x squared plus 3x is equal to 6x plus 4. And now we can bring everything on one side of the equal sign. We get x squared plus 3x minus 6x minus 4 equal to 0. So our quadratic equation is going to be x squared minus 3x minus 4 equal to 0. So this will be our quadratic equation. We can use the quadratic formula and then find out the value of x. And let us see how we do that. So over here, a is 1, b is negative 3, and c is negative 4. So we can apply the quadratic formula x equal to minus b minus 3 plus or minus square root b squared minus 3 squared minus 4ac minus 4ac over 2a. That's the formula. So x is going to be equal to, if you simplify this, 3 plus or minus square root 25 over 2. And that is going to be x equal to 3 plus or minus square root 25 is 5 over 2. So we will have two roots. 3 plus 5 is 8 over 2, 4, or 3 minus 5 is minus 2 divided by minus 2 is negative 1. But why cannot x be negative 1? Because x is representing the breadth of the park, which cannot be negative. So the breadth of the park is 4 meters. The breadth of the park is 4 meters. And the length of the park is 3 more than the breadth, which is 7 meters. You can verify taking the area of it and you will get it right. Good job. Represent the word problem in the quadratic equation, then apply the quadratic formula to find the value of x. That is the whole process involved in the word problems of quadratic equations. Let's try this. A motorboat whose speed is 18 kilometers per hour in still water takes 1 hour more to go 24 kilometers upstream than to return downstream to the same spot. Find the speed of the stream. Let the speed of the stream be x kilometers per hour. Then the speed of the boat upstream, meaning against the river, is 18 minus x kilometers per hour. The speed of the boat downstream will be 18 plus x kilometers per hour. We have done such type of a problem earlier. The time is nothing but distance over speed. So the time taken to go upstream is 24 kilometers, that's the distance the boat has traveled, divided by the speed of the upstream, which is 18 minus x. What is the time taken to go downstream? It will be 24, that is the distance, divided by the speed downstream, which is 18 plus x kilometers. And the question says that the difference between the upstream and the downstream movement is 1 hour. So when we take the difference, the question says the difference of the boat upstream and downstream is 1 hour. So 24 over 18 minus x minus 24 over 18 plus x is equal to 1. Now we can take this and solve the equation. And let's see how we go about doing this. When we take the LCM, we are going to get it 24 times 18 plus x minus 24 times 18 minus x equal to 1 times 18 minus x times 18 plus x. And we have done all these type of problems in the lower grade. If you open the brackets, you multiply, you subtract the like terms, you move everything on one side of the equal sign, you land up with the equation x squared plus 48x minus 324 equal to 0. And now you can easily find out the value of a is 1, b is 48, and c is negative 324. Take these values of a, b, and c, use it in the quadratic formula, and you will get the value of x as 6 or negative 54. But since x is the speed of the stream, it cannot be negative. So we ignore the root negative 54. Therefore, x is equal to 6 gives the speed of the stream as 6 kilometers per hour. Remember this, the three cases? If a quadratic equation is of the form ax squared plus bx plus c, you will have two distinct roots if b squared minus 4ac is greater than 0, if this is positive. You will have two equal roots if b squared minus 4ac is equal to 0. And you will have no real roots if b squared minus 4ac is less than 0. So what is b squared minus 4ac called? It is called the discriminant. It is called the discriminant. We have done that at the beginning of the lesson. Now let's take a problem and just apply this discriminant and find out what is the nature of the root. Let's apply this discriminant concept into this problem. Find the discriminant of the quadratic equation 2x squared minus 4x plus 3 equal to 0, and hence find the nature of the roots. So over here a is 2, b is negative 4, and c is 3. And our discriminant is b squared minus 4ac, which is going to be minus 4 squared minus 4 times 2 times 3. And that's going to be 16 minus 24, which is negative 8. And this is less than 0. So if b squared minus 4ac is less than 0, it will have no real roots. So hence this quadratic equation has no real roots. So this is how you apply the idea of discriminant into the quadratic equations to find out how many solutions it has. Let's try this problem. A pole has to be erected at a point on the boundary of a circular park of diameter 13 meters in such a way that the differences of its distances from two diametrically opposite fixed gates A and B on the boundary is 7 meters. Is it possible to do so? If yes, at what distances from the two gates should the pole be erected? So let us consider P to be the location of the pole, the required location of the pole. Let the distance of the pole from the gate B to P be x meters. So from B to P be x meters. And the question says that the difference of the pole from the gates is 7 meters. That means BP minus AP is going to be 7 meters. BP, we have taken it to be x, minus AP is going to be 7 meters. So AP is going to be 7 plus x, or x plus 7. So this distance is going to be x plus 7 meters. Now the question says that this AB, the diameter, is 13 meters. Since AB is the diameter, can you tell me what is this angle going to be? Angle BPA is going to be 90 degrees. Why? Because we learnt in our lower grades in the properties of circles that the angle formed at the circumference, at the boundary, by the diameter is 90 degrees. Now this becomes a right angle triangle. Triangle APB is a 90 degree triangle. Can we apply the Pythagorean theorem? Remember the Pythagorean theorem? C squared is equal to A squared plus B squared. So if we apply the Pythagorean theorem, we have x plus 7 the whole squared plus x squared is going to be equal to 13 squared. So if you open the brackets, x plus 7 the whole squared is in the form a plus b the whole squared. So we can apply the formula a squared plus 2ab plus b squared. So x squared plus 14x plus 49, and the x squared as it is equal to 169. And now if you simplify, you get 2x squared plus 14x minus 120 is equal to 0. And since all the numbers can be divided by 2, if we divide by 2, we get the quadratic equation as x squared plus 7x minus 60 is equal to 0. Now this is a quadratic equation. But the question is saying, is it possible to do so? Can we erect the pole at that location? How do you go about finding that out? Remember the discriminant. Is it possible to find out whether there exists a solution for this or not? So let's use the discriminant and find out the possibility. So for the quadratic equation, let's first figure out what's b squared minus 4ac. b squared minus 4ac, 7 squared minus 4 times 1 times minus 60. And if you simplify that, it's going to be 289. So that's greater than 0. So it is possible to erect the pole. So now we can use our quadratic formula and figure it out. X equal to minus b minus 7 plus or minus square root b squared minus 4ac, which we already did, 289, over 2a, 2 times 1, which is 2. And if you simplify that, minus 7 plus or minus 17 over 2. And when you solve this, x is going to be equal to 5, or x is going to be equal to negative 12. But we cannot take negative 12. Why? Because x represents the distance of the pole from B. Remember in the diagram? So the distance of the pole from gate B. So the pole has to be erected at 5 meters from gate B, because this was x. And AP, that distance from the gate, was x plus 7. So 5 plus 7, 12 meters. So it is possible to erect the pole from gate B. It's going to be 5 meters apart, and from gate A it's going to be 12 meters apart. This was all about the quadratic formula, its discriminant, and how to use the quadratic formula to figure out the roots of a quadratic equation, and based upon the discriminant, how to find out whether it has one root, no real roots, or 2 roots of the equation. So this completes the lesson on quadratic equations. using quadratic formula. I really appreciate your effort in watching this video, and I hope that you are doing the calculations, the lower grade calculation, the simplification, and I hope the explanation is clear enough for you to pursue more problems on your own, which I expect you to do it. Keep practicing, for practice makes things easy. Thank you for watching this video.